everyone.
Hello.
Thanks for attending today. Can everyone attending via Teams hear me? Is it coming through?
Do you want lights on, Holly? Is it really bad?
Do you think lights on with her? I think lights off probably. Yeah. Okay. Well, this session's been recorded, so for anyone who's unable to attend today in person, there will be an accessible version available on SharePoint to look back on later. So I thought it'd be a good opportunity for me to give a brief kind of run through of geoarchaeology, what it is, the type of work that we're involved in, and introduce myself. So I'm Holly, I'm the new geoarchaeology manager at Cotswold, and hopefully by the end of this presentation you will have a greater understanding of what geoarchaeology is, the role of a geoarchaeologist, the type of work we undertake, and how subsurface investigations can help to reconstruct past environments. So firstly, what is geoarchaeology? Does anyone have any preconceptions about what it is, or have you worked with a geoarchaeologist in any format, whether out in the field or in the office? Anyone brave enough to?
Examining the sediments themselves and the soil formation processes.
Yeah, exactly. So, as defined by Historic England, geoarchaeology is the application of earth science principles and techniques to understand the archaeological record. So it combines a variety of different disciplines, primarily geology and archaeology, and it studies the stratigraphical sequence beneath the site to understand more information about how the deposits got there, why are they there, how were they transported, and how have they built up over time. Through greater understanding about why the sediments are there and how the environment's changed over time, we can then think about how humans in the past may have interacted within that landscape, and in turn where archaeology might be preserved and might be present. So, do certain deposits preserve archaeology better than others? The short answer is yes. Archaeology, if present, can be found in any sediment type. However, some environmental conditions may increase the likelihood of survival for archaeological remains and paleoenvironmental indicators. So, waterlogged deposits such as peat and alluvium are great preservers. Typically, they are anaerobic, so they act as a barrier, sealing the archaeology and protecting it from decay. Through examination of deposits such as alluvium and peat, past environments can be reconstructed and the potential of the site can be assessed. Reconstructing past landscapes. So fundamentally, all sediments tell a story about their depositional environment. So just the fact that they're there, they're present, it tells us information that's valuable for understanding how the environment's changed. So here I've got a hypothetical site with very different types of environment that you might expect to encounter. So going from borehole core 1, you can see that at the base of the borehole core you've got a coarse sand deposit overlain by peat, and then alluvium, and capping the sequence is modern subsoil and topsoil. So from looking at the deposits present here and knowing its location in proximity to a river nearby, you could interpret this as a kind of floodplain environment. So you've got the sands at the base that would be quite coarse, and they would have been deposited by a fairly fast moving channel kind of environment, or a flash flood from the river banks. This is then, above this has the peat, so you can then understand that the environment's changed. There is no longer water present, the environment has become terrestrial, and you've got vegetation growing, so trees, plants, vegetation that's growing and dying and building up throughout a period of stability before then there's another seasonal flood event where you have the alluvium coming in, sealing those peat organic deposits. So the alluvium would be the silts and clays from the river flooding event. Then water has receded, and then you've got room for the topsoil and subsoil to form above this. The second borehole is an example of a typical alluvial deposit. So it grades upwards. At the base you've got the gravels, so much coarser clasts, overlaying by sand, so it's grading upwards, become medium and fine, and then alluvial deposits on top, so you've got the silts and sands. And this might represent a former paleo channel within a site. So a channel that was once active, so those sands and gravels that are transported by a kind of medium or a fast flowing water environment. And then as that channel is going out of use, there's no longer as much water running through it, you're getting more finer sediments building up that would kind of settle out of the water body in a much slower moving stream of water. And then finally, you've got a beach environment. So this would contain deposits that you would expect to see if you went to the seaside. So it's the gravel, sands, you've got clear evidence of grading, so you've got the much larger gravel class towards the base fining upwards, so you've got more medium and then finer gravels, and then grading upwards towards more sand particles. You might also find other inclusions such as marine shells that would tell you this was a marine environment. These deposits were laid down by the sea because of those shells that are present. So any deposits that are present, they all tell us a story about how they got there and why they're there, and help to provide actually quite a lot of information. You might just look at it and think, oh, it all looks like mud or it all looks like sand. But actually we can get quite a lot of information from this. So what is the role of a geoarchaeologist? Primarily, this is split into three. So it's split between fieldwork, laboratory work, and desk-based work. Fieldwork. This would include working in support of archaeological field investigations, conducting standalone geoarchaeological surveys, and monitoring geotechnical ground investigations. So the work that we would conduct in support of archaeological field investigations would typically be attending site to advise on sampling strategies. There may be deposits and features present which the field team are unsure of. They're not sure if it's man-made, so an archaeological feature, or if it's a natural process, like colluvium or alluvium on site. So a geoarchaeologist might attend to provide a greater understanding of the deposits, to advise on how to sample them, and then also to take monolith samples through the sections and features. We would also conduct geoarchaeological surveys, so this is geoarchaeology led. The purpose of these would be to acquire sediments from depth to inform on geoarchaeological potential. So again, it's targeting these deposits of potential significance so that we can understand how the sediments, what sediments are beneath the ground and how they've got there and how they've formed over time. And then collecting samples that could be used for further assessment and analysis. And monitoring geotechnical ground investigations. Essentially, we're interested in the same data, so it saves a lot of time rather than the engineering company going out and conducting a borehole survey and then the geoarchaeological team having to go out to the same site and drill essentially the same boreholes in similar locations. It would save the client a lot of time and money if we can collaboratively work together at the same time. So the earlier we know about projects in the pipeline, the greater the chance that we can get involved at an early stage and help to advise the client and the project team on whether it's worth having a geoarchaeologist attend. The data that we're looking for is the same, so the engineers on site are looking to acquire sediments from depth to understand what sediments are present, understand the structural properties to inform their design of their development. So foundations, piling, that kind of thing. They want to know how deep's the bedrock, how can they make their development structurally sound. For us, we're interested in the same data, so it's the same boreholes, the same logs, but for us it's answering different questions. So it's everything typically above bedrock that may have had human influence, and we want to know how the environment's changed and where humans were interacting within it. So recording things like the location data is crucial, the elevation and coordinates of the borehole locations. Recording the superficial and solid geology. So here in the middle image you've got some borehole cores from depth. It's like an apple corer, so it takes those sediments from situ at depth up to the surface for us to see. So yeah, you can go down, in that image it's down to 10 metres, and you can see an exact sequence as it is beneath the ground. There might be opportunities to take samples for any deposits with significance and record archaeology if it's present. Laboratory work. So this follows on from the field work, so often we would get either borehole cores or monolith cores back to the lab, and we can carry out more in-depth, detailed assessments of the sediments present. So we'd be looking at much greater detail, so things like the colour according to the Munsell chart, any what sediments are there any inclusions, what are the upper and lower boundaries like between the sediments, so are they sharp, indicating that it was a fast changing environment, or is it very gradual, indicating that something's happened slowly over time. And desk-based work, so drawing upon all the information gathered from both the field and the laboratory, we would be looking to then produce assessment reports and deposit models, so summarising and joining together all of that information that's been gathered. Deposit models can come in 3 forms typically, so we'd either have a digital elevation model. So here you can see a deposit mapped across the site, so you can see the spatial distribution of the deposit. You can equally see the upper height, so where I was talking about the upper and lower boundaries of deposits beneath the site, it's really important to have those coordinates and elevations of the top of the borehole core or the test pit or hand auger sample, so that we can stratigraphically map below the ground and see at what level do these deposits appear across the site. So for instance, this maps the glaciofluvial deposits, but it could be peat, it could be alluvium, it could be any of the deposits encountered within a site. We can single them out and produce a visual image to show the height of where they're encountered. So this is really important when thinking about the impact of a development. So again, things like foundation designs, piling. If a deposit was only appearing at 10 metres below the ground surface and the foundations were only going to 5 metres, you can confidently say that this deposit's not going to be impacted by the development. However, if the deposit was present at 3 metres and the foundation was 5 metres, then this might warrant further work, whether it's a watching brief or further assessment on targeted borehole cores if it's potentially significant. So it's really useful information to use historic data, so any ground investigation that has happened previously within the site, you can use that data, so those borehole logs from the engineering company, you can use those to input into the model, as well as adding new additional data to it. Likewise with thickness plots, you can map different sediments across the site. So for instance, if this was representing peat across the site, you could say that, it might be useful information for the client and the local planning authority to know that in the northwest corner of the site, you've got the thickest deposits reaching up to 4.5 metres of peat, whereas in the southeast of the site, there's not much present. So it could inform our watching brief. So it might be that we don't need to monitor certain boreholes within the site, and actually we'll concentrate our watching brief to those areas that are targeted for the greatest potential. It could equally inform if we were undertaking a standalone geoarchaeological survey, because it might be that, great, we know that's where we're going to get the thickest sequences of a deposit that has geoarchaeological potential, so that's where we're going to stick our boreholes. We're going to give ourselves the best chance to acquire those sediments and get the most full sequence that we can. So yeah, it provides really valuable information. And transects. So again here, it's a subsurface cross-section across the site, and using the industry standard software you can input all of the sediment boundaries. So like I was saying, the kind of upper surfaces and lower surfaces of each deposit you can input into the software and produce these models. This transect was taken from a coastal site. So you can see in orange there is Storm Beach deposits. So I think towards the west, the first borehole here was actually on the promenade. So you've got a huge amount of made ground there, as would be expected, and it's truncated any Storm Beach deposits that were present. And then moving across more towards the east, you've got a build-up of these Storm Beach deposits, and if you can kind of imagine how they would have formed, it'd be high energy events that kind of flung onto the beach by the ocean, creating a big mound of these gravels essentially. And then behind that, you can see that there's an area here where alluvium and peat has formed, so sheltered by those Storm Beach deposits. Behind them, you've got probably a waterlogged area or areas where loads of water is kind of gathering, either groundwater or from the ocean, that is conducive for vegetation to grow and peat to form and alluvial deposits to be laid down. So it's really helpful to be able to visually see the distribution of deposits across the site, and it can really help to enhance our understanding of the landscape and how humans may have interacted within it. Here is a list of the geoarchaeological services that we offer. I thought this would be a good thing to include for awareness, just if you've got any upcoming projects that you think, oh, watching that presentation, actually it might be a good idea to get a geoarchaeologist involved or to ask some questions about could there be any potential significance. So yeah, we can produce the reporting elements, deposit models, we can attend site and carry out field work, and also provide advice and liaison. So this of course could be tailored to the project specific needs and can include liaison with the local planning authority and any statutory bodies as well. If this has piqued your interest, obviously this is just a kind of brief overview of what geoarchaeology is and the type of work we do, but if you are interested to learn more, these are some great resources that provide a really good background context for geoarchaeology. So you've got the Historic England Best Practice Guidance on the left, and on the right you've got Deposit Modelling and Archaeology. So this was produced based on a series of case studies in support of the best practice guidance. So if you're interested in learning more about geoarchaeology or deposit modelling or archaeology, then these would be two really good resources to give a look at. So hopefully you now have a clearer idea of what geoarchaeology is, what the role of a geoarchaeologist is, and the type of work we undertake, and also how the subsurface investigations can help to reconstruct past environments. If you would like to discuss further, if you ever have any questions, then please do get in touch. I'm always happy, whether via phone or email, to discuss, and we can we can have a chat through any upcoming work, reporting or sampling strategies. So yeah, just give me a bell. Are there any questions?
I don't think so. I don't have any.
No?
Yeah, I've got one. Just a quick question.
Jesus.
Okay, sorry.
Yeah, basically, it just occurred to me, and I'm not sure really whether it's relevant to what you do or not, but there was a buildings project, where we had an earthwork fund or traverse, which had existing borehole data. So it was probably late 19th century, sort of early 20th century. But so if I was to get hold of that data and if I was to give it to you, would you be able to tell me if it comprised basically of local geology or whether it was specialist material that had been brought to site from elsewhere? It's kind of not an essential for the project, but it would be kind of a nice to know, because obviously you know whether it was a more specialist construction or, I mean, is that something you could do or not?
Yeah, definitely. I think if there's already historic information present, so if there's already been past investigations and we've got the borehole logs, that's definitely something that if you got in touch and provided that data, I could have a look through and see what depositional processes they represent. Is it local? Is it natural? Does it have potential? And it might be that it could be of potential significance, and in which case then we can look at reporting outputs to kind of integrate into a wider report, or it might be that it's not that significant, and it's just good to know.
Yeah, well, this is it. It was more, I was just thinking of this particular place. I mean, it was probably just more, nice to know. Perhaps it was more significant than people thought, or whatever. But no, that's good. I was just curious. That was all.
No worries. Any other questions? Should we leave it there then? I don't think anyone's got their hand up. I was looking at John's picture.
Yeah.
His picture's got his hand up, but not him. Okay, brilliant. Well, thank you for attending, and this recording will be uploaded to SharePoint. So, if you need to refer back to it for anything, or if anyone else would like to watch it, then they'll be able to watch it.
Cool.
Thank you.
Brilliant.
Thank you.
Thank you.
Thank you.